One of the earliest triumphs of information technology occurred to solve a problem faced by the US Census. The US Constitution requires that a census be conducted every 10 years. However, by 1880, the US population had grown so much that the process of tabulating all the data was becoming a problem. In fact, the 1880 census wasn't tabulated until 1887. Well, the census directors realized that the upcoming 1890 census would be an even bigger job, which raised the possibility that it might take more than 10 years just to finish tabulating the data. And that means they wouldn't even be finished with the 1890 census before it was time to take the one in 1900. They knew they needed a different approach. Well, the Census Bureau turned to a former census employee named Herman Hollerith, who developed for them a tabulating machine to count data entered on cards. His tabulating machine was able to take the census data from 1890 and process it in about a year. Wow! This tabulating machine is considered a predecessor of our modern computers. It was designed to process large sets of very similar information. Now, Hollerith kept on developing improvements to the tabulating machine, and ever since we've never had to worry about the ability to tabulate the census. Eventually, Hollerith's company and 3 others merged to form a company called CTR. And CTR later changed its name to one you're probably more familiar with, IBM. The need to work with large sets of similar data and keep up with it in an organized way was not unique to the census. In fact, there are so many times that we want to deal with data like this that just about every programming language provides a tool for organizing data like this. In Python, these are lists. Lists are one of the programming features that Python supports particularly well. Python makes it very easy to create lists and do all sorts of things with them. If you use lists in other programming languages, you don't have quite the flexibility that you do in Python. Let's first see what life is like without lists. Say we want to store a group of credit card purchases. We're going to store the amounts of each purchase so that we can do something with them later, like find the average. So, say our first purchase is $3.50. We can store it in a variable first amount, like you see here. Okay, let's say we had 2 more purchases, a $5 one and a $10 one. Well, we would need more variables, second amount and third amount, to store those. If we wanted to compute the average, we can do so, but you can already tell this is starting to look pretty ugly. But what if we had more transactions, like 10? This is quickly becoming unmanageable, and you can imagine how unworkable this would be if there were 100, 1,000, or 1,000,000 of these. Well, this is where the array, or list, comes in. In much of programming, an array is the more general term, but in Python, the usual and broader term is list, with array being used to refer to only one specific type of memory-efficient list. As beginning programmers, though, we don't need to worry that much about memory efficiency, so we'll stick with Python's more general and flexible list. Now, variables always correspond to a box in memory. So, each of the variables we've looked at so far is one box that can hold one value. Well, when we think of a list or an array, we have a whole stack of these boxes. We give one name to that whole stack of boxes. This is going to let us organize our data to keep common things together. Let's look at some of the cool things that you can do with lists. Let's first look at how you can create a list in Python. In Python, we write lists as a series of values, separated by commas and enclosed in brackets. The command you see here might be storing the daily high temperatures for a week. So we assign the variable highTemps a list, specified by square brackets containing 7 values separated by commas. In memory, you can think of this as 7 boxes being created, each with a different value contained. Now, let's say that we want to actually look at one of those values. Each of those boxes in the list is going to have a whole number associated with it called its index. The boxes are going to be numbered consecutively, but here's a really important thing to take note of. The first box is numbered 0, not 1. In pretty much all of computer science you'll find this. We start numbering with 0. So, the first box is 0, the second one is 1, the third is 2, and so on. For our temperatures for the week, we would have the items of the list numbered 0 through 6. The reason why our first index is 0 is related to how lists are stored in memory. When we assign a list to a variable, what that variable will store is actually the location of the first element of the list in memory. So, to find where an individual element of the list is, we'll add its index to the location of the first element. So the first element will be right at the position stored. It's offset by 0 from the location stored. The second element is 1 memory unit after the beginning, and so it will have index 1, and so on. Okay, we've said how each element or value in the list is going to have some index. If we want to get the value in one of those boxes, basically get an element out, we need a way to refer to it. We can refer to an element of a list by putting the index in brackets right after the variable name. Say we had our temperature list from before, and we wanted to print out the first value. We could print out daily high temps sub 0. By the way, that's how I'll often refer to an array element, by saying sub. It's shorthand for the word subscript, which is the mathematical way that we'd usually represent an array element. In this case, we would print out the 0th element of the list, that is the first element, or 83. Printing out daily high temps sub 4 would print out 79. So, remember, the variable name is referring to the entire list. Putting the index in brackets allows us to get one element out of that list. The index doesn't even have to be a number, it can be a variable, as long as that variable has an integer value. So, we can assign the value of 1 to I, and then we can print daily high temps sub I and get 80. We can also assign values to the list elements, just like any other variable. So, in the case you see here, writing daily high temps sub 3 equals 100, that assigns the value 100 to element 3, which is the 4th element. Let's practice this a bit. Let's say we want to create a list of how many days are in each month of the year. First, how would we create this list? Here's one way. We create a variable. I chose to call it days in month. And then in square brackets, we list the number of days in each month. So, we list the number of days per month, 31 for January, 28 for February, and so on. Now, what if we wanted to print out the number of days in the first month? How would we do that? We would print out days in month sub 0. Remember that we would have to use the subscript 0. If we wanted the number of days in September, which is the 9th month, we'd need to print out days in month sub 8. Finally, let's allow our list to adjust to account for a leap year. Let's say that we know it's a leap year. What command would we give to update the list appropriately? We'd set days in month sub 1 to the value 29. Or we can be more flexible and create a new variable named year, and use this to determine whether or not to make the leap year adjustment. For this, we can put in a conditional to check whether the year is a multiple of 4. I'll ignore the special cases for leap years when the year is a multiple of 100. So, if it is a multiple of 4, we'll make the adjustment to days in month sub 1. Now, let's think for a minute. What if we wanted to print out all the elements of a list? Say, just this list of 7 temperatures. How might you write code to do that? Well, what about using a loop? How would we create a loop to print every element? We can loop through all the different index values and then print out the value of each element of the list. Here's one way we might write a loop like this. We pick our index, in this case I, and we let it range from 0 to 6. Remember that the command range7 means that it will take values starting from 0 on up as long as it's less than 7. So in this case, it takes the values 0 through 6. See, you've already seen the idea of counting by starting at 0. So, for the code we see here, it's going to print out the element for each of those indices, which will print the whole thing. Now, say we didn't know how long this list was. How could we do this? Well, there are actually a couple of ways. One way we can do it is we can first find out the length of the list. Fortunately, there's a command to do this. The len command, short for length, is a way to get the length of a list. You put the variable in the parentheses, and the command returns the number of elements in the list. So, in this case, we get that length and it comes out to 7. So, remember our previous loop where we had a range of 7? We could replace the 7 by len, and then in parentheses, daily high temps. And that would be the same result. Notice that this code would work regardless of the size of the list. The list could have 1 element or 1,000, and it would all work just fine. There's a second way we can do this. It's a little more complex to understand, but in many cases it's easier to write and it's more useful. If we want to loop over all the items in a list, we don't even have to use an index, at least not directly. We can use a for loop like this. That's right, we don't use a range command. We just say, for all the I in the list. Now, what do you think is going to be printed here? This code is going to print off all the values in the list, just like before. Is that what you expected? Let's look at what's happening here. When we set up a for loop, like this, the variable is going to take on the values of the individual elements of the list. So, when we start the loop, I will get the value of the first element of the list, which is 83 in this case. When we print I, we get 83. On the next iteration of the loop, I gets the value 80, and that's what we print. And this will continue until I takes on every value in the list. Now, note something important. I is getting assigned the value from the list. So, if we modify the value of I, it does not change the value in the list. Let's look at this slightly modified code, where we set I to 0. On our first iteration of the loop, I takes on the value of the first element, 83. Then, when we encounter the line I equals 0, it's going to change the value of I, but not change the value in the list itself. If we wanted to change the temperature values in the list, we need to use a different loop, like the index values that we saw earlier. Notice that this code, where we assign a value to the elements themselves, would set all of those values to 0. Let's practice a little bit more. Assume we had our days and month list from earlier. Let's say that we wanted to compute the total number of days in the year. To do this, we'll have a variable, and we'll add the number of days from each month to that variable. Now there are a few ways we could do this. See if you can come up with one of them yourself. Okay, we're looking for a sum, and its name can be numDays, which we'll initialize to 0. We can loop through from 1 to 12 and add the number of days on. In each case, we give the list name and then the element number, I in square brackets. In this case, we know that the list will have 12 elements, since there are 12 months in the year. We could have been more general and made the range cover a list of changeable length. A different option would be to actually loop through the different elements. In this case, we let I take on the values of the list elements by writing for I in days and month. And so we will add I to the sum each time. As an aside, since computing sums is a pretty common thing, there's actually a command in Python that will do this for us. We just call the sum command, putting the list into the parentheses. Okay, that gives us all the fundamentals of working with lists. However, Python gives us a bunch of other things we can do that make lists even more useful. In particular, I want to go over appending, indexing, slicing, and lists of lists, because each of these are part of what makes Python a particularly useful language. First, let's look at another way to build up lists of elements. We've seen how we can create lists by separating items with commas, like you see here. Well, we can also merge lists together by using the addition operation. This creates a new list by taking all the elements in the first list and then appending on those from the second list. In this case, we create list 3 by adding lists 1 and 2 together. We can also increase a list by using the plus equals operation. This will let us append additional items onto the end of a list. You can see an example here, where we've appended list 2 onto the end of list 1. Now, if we don't have a list, but rather just one item, we can also add it onto the list. The format for this command is again going to look a little weird right now, but you've seen things like it before when we were closing files. And eventually we're going to explain why commands look like this. There's an append command that lets us add one element on to the end of an existing list. Here's what it looks like. We have the name of the list, then a period, then the word append, and then in parentheses the thing that we want to append on. In this case, we take list 1 and we add on the value 3.9 to the end of it. Now, appending can be really useful for building up lists. There are many times when we want to keep adding things to a list, but we don't know at first how long it's going to be. For instance, maybe we want to get a list of all the ages of the people in a group. We don't know ahead of time how many people there will be, so we just keep adding on to the list until we're done. Take a look at the code here. We start out with an empty list, and we ask for ages. Every time we get an age, we add it onto the list. If the user enters -1, which is obviously not a valid age, we take that as the indication that we're done. Notice that this code will work to collect a list of all ages, whether there are no people or 20. Besides different ways to build up a list, there are also different ways to index into a list. We've already seen the basic way we index into a list by putting the element number of the list in brackets. This is the example we've looked at before, where we have a list of temperatures during a week, and we print out the first temperature. Well, what do you think will happen if we put in an index number that's too large? Remember that the array has just 7 elements, so they'll be numbered 0 through 6. And here we're trying to access element 7. Well, in this case we get an error saying that we're out of range. That's actually a good thing. The computer is not letting us access something past the end of the list. Okay, what if we put in -1 for the index? What do you think will happen? Well, if you guessed that it would be an error, that was a reasonable guess. But Python has a better idea. Putting in -1 actually gives us the value of the last element of the list, 86. This is a convenient tool in Python to let us pull items off of the end of a list. And this continues. If we look at index -3, we actually get the third item from the end, or 79. Python also lets us pull out a portion of a list with a pretty cool operation called slicing. With a slice, we pick where to start and where to stop. So, we don't have just one index value, we actually have a colon separating 2 values. You can think of these values just like in the range examples we saw when we were working with loops. The first value, which is A in the code here, is the starting point. The second value, which is B in this example, is the number that you want to stop before. Remember that the index of the first element in the list is 0. So, for example, if you want the first 3 elements, you would enter 0:3, saying that you want elements 0, 1, and 2. If you want elements 4 and 5, you could enter 4:6. Now, if you leave off the number before or after the colon, it means you want to start from the beginning, or go to the end. So, the first 6 elements would just be :6, leaving off the first number because you want to start from the beginning. The last 3 elements would be -3:. And if we just put a colon, it means from the beginning to the end, which is another way of saying we want a copy of the entire list. Let's look quickly at how you could use this with our temperature example. Let's assume that there are 7 days in the week, starting with Sunday. If we wanted just the temperatures on weekdays and not weekends, we could take the slice 1:6. Because counting starts at 0, this would leave off the first day, and because of the way Python reads a range, this would also leave off the 6th, which is the last day of the week, leaving us with the rest. Also, notice here that if we print out the list, we see the brackets and everything. Slicing can let us do some interesting things. We can reassign values to slices, for instance, replacing part of a list with another list. For example, look at this code. In this case, we've deleted all the weekdays from our list, leaving us with only the Sunday and Saturday temperatures. The slice operation took that middle part of the list and replaced it with an empty list. Now, let's say that we actually wanted to insert some new values into the list. We could take a slice specified as 1:1. Now normally this slice would not mean much. It would be empty, since there's no value starting with 1 but ending before 1. However, in this case, the slice refers to the spot right before element 1. So, when we set that slice to some new list, it's like we're inserting that list right in between elements 0 and 1. If we wanted to insert the new values at the beginning, we could put them at slice 0:0, or just plain :0. And if we wanted to put them after the last element, we could put them at 2:2. Notice that while an index like 2, which is one past the highest index value, is not allowed normally, it is allowed when slicing. Let's practice with slicing a bit more. Remember our array where we stored the number of days in a month? How would you get a new list for just the summer months, with the months June through August? Well, we would just use our slice operation. June is the 6th month, which means we'd start with element number 5, remembering that numbering starts at 0. We'd want 3 months, which would mean our ending index is 3 more, or 8. This slice will get the days per month for the 3 summer months. Now, what if I wanted the number of days for the first 3 months of the year, and then also for the last 3 months of the year? How might I generate those two lists? In this case, we can get the first 3 elements by slicing with just :3, and the last 3 elements by slicing with -3:. That is, we can take all elements from the beginning, but with index less than 3, and then take elements starting 3 from the end, all the way to the end. Okay, let's try one final thing. How might we form one list containing just the first 3 and last 3 months worth of data, but not the 6 months in the middle? Here are 2 ways of doing that. We could take the 2 lists we just formed, the first 3 months and the last 3 months, and add them together to get our new list. A second option would be to start with a copy of the entire list. That's the slice with just a colon, meaning a slice from beginning to end. Then we would take the middle of that list, that's the slice from 3 to 9, and set it to an empty list. This would also leave you with a list containing just the first 3 and last 3 months worth of data. Now, I want to tell you something that might surprise you a little. We've actually been using lists in this course for a long time, since the very first lecture, in fact. You know all the strings we have where we're using big lists of characters all strung together? That's right, strings are actually a slight variation of a list. That means that many of the things we've just been looking at with lists can also be done with strings. So, if we have the string Arthur, King of the Britons, we can slice out the first 6 elements and get Arthur. Or we can get elements 8 through 11, which is king. Or we can get the last 4 characters, which are tons. Cool, huh? Basically, slicing on strings works just like slicing on lists. The one big difference is that we can't assign to a string the same way we did with lists. That is, we can't delete parts of strings or insert strings in the middle like we were doing with lists. You need a separate set of commands to manipulate strings. For example, if you take the string and follow it with period lower parentheses, you get a new string, the same as the previous one, but all in lowercase. Or if you follow it with a period capitalized parentheses, you get a new string that capitalizes only the first letter and has the rest in lowercase. Notice that we can make a list out of anything. We can have lists of integers. We can have lists of floats. We can have lists of strings. And we can even have lists of lists. Here is a list of 3 lists, each of which has 3 elements. If we print out the first element of this list, what do you think will happen? Well, in this case, it prints out element 0 of the list of lists, which is the list 456. How about this one? Notice that we have 2 sets of brackets here. What do you think will happen in this case? Okay, the output here is 7. To see why, let's look at the statement. What happens is that we first find list of lists sub 2, which is the list 789. Then we take element 0 of that list, which in this case gives us our answer, the number 7. We could even have lists of lists of lists, or lists of lists of lists of lists. That's a tongue twister. The idea is the same with all of these. Lists of lists can be very useful. Say you want to represent a chessboard. A chessboard has 8 rows and 8 columns, and each space can either be empty or can contain a piece. We could represent a chessboard by making a list of 8 rows of 8, each of which contains a string giving the piece that it is in that square. The example you see here shows one board configuration, where the letters indicate the various chess pieces, and a period indicates an empty square. Now, actually getting the computer to play chess, well, that's a little more complicated. And the way we'd present the data to a user or get information from a user about a move or the state of the board, that would be different. But this basic structure, this is the way that we would represent something like a chessboard within the computer. Okay, I want to mention one more thing, though it's as much of a caution as it is a benefit. One thing that Python lets you do is create lists in which you have a combination of different types. Most languages require an array to be all stuff of the same type. But in Python, it's okay to have a list of items like this, with an integer, a float, a string, and another list. There are times that things like this are useful, when you're wanting to group unlike things together. For example, maybe we want to have credit card information. So we create a list with the name of the credit card number, and the expiration date, all in one list. But there's a better way of grouping stuff across different types, and that's objects, which we'll learn about later. Anyway, this is one of those things that's allowed in Python, and if you do have a list with mixed types, Python will let you treat that as an object. Before we go on, let's look at one other thing that's very similar to a list that Python supports, the tuple. A tuple is like a list whose values can never change. And unlike a list, it often will contain different types of data. Tuples can be specified by giving a list of values separated by commas. Here's the example we just saw with a credit card, where there's a variety of different stuff put together. In this case, credit card is a tuple, instead of the list like we had before. If we print out a tuple, it shows up as having parentheses around it, not square brackets. We can assign values from a tuple to a set of variables, separated by commas. In the example, our car tuple has a car make, model, and year, and we can assign the tuple to 3 separate variables, the make, model, and year. We could have done this with lists also, though again, that's not the best use of lists. We can also access parts of the tuple using indexes or slices, just like with lists. However, we can't actually change the value of a tuple once it's created. So, imagine that we're responsible for keeping track of today's population census, and we have information about the number of people in each of the households in the US. You can see now how we could potentially store that information in a list, while it would be nearly impossible to store that information in a bunch of individual variables. In our next lecture, we're going to look at how we can put together some of these tools, like lists and loops and files, to make a more complex and interesting program that lets us analyze weather data. See you then. Okay, here's an exercise you can try to get some practice using lists. Write a program that asks a user to type in 2 pieces of information about however many people they want, a person's name and then the person's age. And you can have them type stop for the name when they're ready to stop. Then, print out which person is oldest. Need a hint? Try creating 2 lists, one for the names, one for the ages, so that the names and ages are in the same order in both lists. These are called parallel arrays, or parallel lists. Then, figure out from the age list which age is the largest. The corresponding name will be the name of the oldest person. Here's one example of how this could be implemented. At the beginning, we have our 2 lists, one for names, one for ages. We have a loop to keep getting names and ages until someone enters stop. Each time they enter a name and age, we append them to the appropriate list. Then, in the second part, we try to find the person with the biggest age. We start by assuming the first person entered is the oldest. And then we loop through all the other ages, and if we find an age bigger than the biggest one so far, that becomes our new maximum. Notice that we keep track of the index for that oldest age. Finally, when we've gone through all the ages, we have the index for the oldest person. So, we print out the name of the person with that index. Ta-da! All done.